Hi, so today we are going to learn about the conditional probability. So as you can see, I have already noted down the definition. The definition says the probability of event E happening is called conditional probability of E given that F has already occurred, and it is denoted as P of E where F has already occurred, right? Or P inside the bracket E bar F and bracket closed, right? So this is how we write the conditional probability. And now let's understand what conditional probability is. So to understand it better, we are actually going to solve a problem, and parallelly we will learn about the conditional probability also, right? So let me note down one problem statement. So here we have a problem statement. The problem statement says 3 coins are tossed. Find the probability of getting at least one head where first coin already showing tail, right? So when we toss 3 coins, what will be our solution space? Our solution space will be this, and the number of elements in this solution space, or the cardinal number of this set S, will actually be 2 to the power 3, where this 3 is the number of coins and this 2 is the total possible outcomes when you toss a coin. When you toss a coin, you can get either head or tails. So there are 2 possible outcomes, and since we are having 3 coins, the total possible outcomes will actually be 2 to the power 3, that is equal to 8. So the number of elements in this set are 8, right? And now if we talk about the event E of getting at least one head. So E is the event of getting at least one head, and the elements of this event will actually be all these. It will have all the 7 elements of set S other than the one where you are getting all tails. So these will be the 7 elements which are favorable of getting at least one head when you toss coins. So the number of elements, or the cardinal number of this event or this set E, is actually equal to 7, right? But here we have one condition. What is the condition? Condition is the first coin is already showing tails, right? So let us define it as event F, and the event F is first coin shows tail. So if first coin shows tail, we'll have 4 favorable outcomes, and they will be these 4, right? And the number of elements in this set, or the cardinal number of set F, is actually equal to 4, right? So these are the different events and our solution space. But what we have to find? We have to find the probability of getting at least one head where the first coin is already showing tail. So this is the conditional probability, and condition is the first coin is already showing tail. So the solution space, or the sample space, is actually shifts to this set. This is the set which becomes our new solution space, because this is the set which is showing all the possible outcomes where our first coin is already showing tail, right? So this will be set F, will be our new solution space, right? And if this is the solution space, what are the favorable outcome of E? The favorable outcomes of set E out of this solution space are actually these 3. These 3 outcomes are actually there in set E also. So the set of our favorable outcomes is actually the intersection of set E and set F, right? And this has 3 elements. First is THH, second is THT, and third is TTH. These are the favorable outcomes, keeping the condition in mind that the first coin is showing tails. So set of favorable outcomes in this case actually becomes the intersection of set E and set F, right? And now it has only 3 elements. That means the cardinal number of E intersection F is actually equal to 3. Right? So when we talk about the conditional probability, our solution space actually shifts to the set of the favorable outcome of event which has already occurred, and the set of favorable outcomes actually becomes the intersection of E and F, the event E for which we are calculating the probability. F is actually the set of all the possible favorable outcomes for that to already happen, right? And now if we talk about the probability of E where F has already occurred, this will actually be the number of elements in the intersection of set E and set F divided by the number of elements of set F, because set F now becomes our new sample space and E intersection F actually tells us the favorable outcome to event E where F has already occurred, right? And what will this be? This will actually be equal to 3 by 4. 3 is the cardinal number of E intersection F and 4 is the cardinal number of set F. And what is set F? It is the set of all the possible outcomes where event F is happening, right? So this is the formula to find the conditional probability, right? And if you have any doubt in set theory, I would advise you to refer to the videos where I am explaining the set theory. Right, so this is one formula. Probability of event E happening where F has already occurred is actually equal to cardinal number of E intersection F divided by the cardinal number of F. F is our new solution space and E intersection F actually represents all the outcomes where F has already occurred, right? So this is one formula, and now if I take this formula and modify it a little bit, if I divide both numerator and denominator of this formula by the cardinal number of our original sample space, it will become n of E intersection F divided by n of S whole divided by n of F divided by n of S. And this is what? This is actually the probability of event E and F both happening together, right? That means probability of E intersection F happening divided by the probability of F happening, right? See, here if we take the sample space S and talk about all the possible outcomes where we have at least one head and tails on the first coin. So these are the possible outcomes where we have tails on the first coin and at least one head, right? So the probability of this event happening where there is tails on the first coin and at least one head is actually 3 out of 8, right? And the probability of F happening, that means getting the tails on the first coin, is actually this. What is this? This is nothing but 4 out of 8, right? And if we solve it further, again we are going to get 3 out of 4. So this is the second formula of finding the probability of E where F has already happened. It is equal to the probability of E intersection F divided by the probability of F. So these are the two formulas, easy to remember, and now I think it will be very useful for you to find the conditional probability of any event happening, right? So this is all for this video, and in the next video we are going to learn about the properties of conditional probability. So keep watching Math Smart and bye bye till then.